Alright, the next few set of directions, this one says write an equation, so it's just making sure you can set up transformations. So here's my parent function. I'll tell you what the parent function is. And it says let g be a vertical shrink by a half. So you need to know what vertical means. Vertical means it's going to affect the y. If you see horizontal, it's going to affect the x. So if it's a vertical shrink by a half, all it means you're going to do is take your original function, which is square root of x, you're going to multiply it by a half. That takes all the y values and shrinks them by a half by multiplying by a half. Then it says followed by moving to the right. If you move right or left, again, that's affecting the x. When it affects the x, it's opposite of what you think. So when it says right, that means you're thinking, okay, if you're going to the right, you would think about adding, but in order to undo that, inside the function, so underneath the square root sign, you need to subtract 4. That is going to, when it's in the function was the square root of x, it's going to move that 4 to the right because it's in with the x and it's a minus. The half out here is going to, vertically, it's going to affect the y, so it's outside the square root and it's going to shrink it by a half. So g of x is equal to 1/2 square root of x minus 4. Alright, the next one. Here's my original function. And it says I want to do a horizontal shrink by a third. So again, horizontal means it's affecting the x. So it's inside this piece of the function. And it's shrinking those x's by a third, which is, again, opposite of what you think. So instead of dividing by 3 or multiplying by a third, we want to multiply by 3. So it's always kind of undoing that when it's inside the function. So 3x will take all the x's and shrink them by a third. Then it says followed by moving it up 4. So if I was already at a minus 3, but I'm going to move it up 4, it means I'm going to add 4 to that. So if I was at negative 3 and I move it up 4, that's going to put me at 1 plus 1. So g of x is going to equal cubed root of 3x, so that 3 is going to do a horizontal shrink. And then because I'm taking this and it was 3 down and I'm moving it 4 up, so that's affecting the y's, I add 4 to that and get plus 1. Okay, so those are my two g of x. When I go to grade this, I'm looking for all those little pieces. You know, did you know you start with this parent function? Did you know that at least that because it was horizontal, it's affecting the x? And then did you know it had to be a 3 instead of a 1/3? And did you know the 4 was affecting the y's because it was vertical, it was moving up? So did you know that you had to put it out here with the y? So all those things I'm looking for when I go to grade those for points. All right, and then let's just also work on the graphing of 15. 15 is a graph that you don't know. You don't know that parent function. It says sketch it, so you're going to use your calculator and then give the domain and range. So I already put that on my graphing calculator. Make sure you have all your plots off so you don't get an error message. If anything's turned on, if you see something like that on your calculator, just arrow up and hit enter. That shuts the plot off. So I type that in, make sure all of that is under the square root. Now I'll just do a zoom standard, zoom 6. That just goes from negative 10 to 10. So I see my graph comes down. I'm not quite sure what happens here, and then it looks like it takes off again right there. So I'll make that sketch. All it says is to do is sketch it, and we'll label it in a second. It looks like it comes down here. We've got to decide what's happening right here. And then there, it looks like there's some empty space, and then it takes off again. So let's trace along there. I see right away that I'm at 0, 0 when I hit trace. So I know it goes down to 0, 0, and look as I arrow to the right, all of these y's are left open. That means they're undefined. There's nothing there. You're graphing nothing at those points. And then all of a sudden when I get to, looks like over 4, but it looks like probably 4, it looks like I'm starting to get some points. So I'm going to do this. I'm going to go second calc value. So I just went second and trace. And I'm going to go to value and I'm going to type in 4 to see what the value is at 4. And I see that's where it's starting at 4, 0. So it comes down this way to 0, 0. And then because I put in a 4, I see at 4, 0, it takes off again. So when I go to sketch this, I should really label this. That point is 4, 0. And it comes down here to the point 0, 0. And obviously then I should draw arrows that it's going on forever in both directions. So what's the domain? Domain are your x values. So all of these x values to the left of 0 are part of your answer. So x is less than or equal to 0. Those are your x's. And everything to the right of 4 is an x value that's been graphed. So x is greater than or equal to 4. So you can write it like that. Or you could say from negative infinity to 0, including that. So then you have to use a bracket. And then from 4, including the 4, to infinity. I don't care which way you write it, but that's your domain. And then your range, the range is your y values. So if you look at the range, that's what y values have you graphed. So now you're looking this way, and you haven't graphed anything below this axis. You start at 0, and it's everything above the axis. So the range is going to be y is greater than or equal to 0. Or if you want to put that in interval notation, starting at 0, including the 0, to infinity. So I don't really care which way you write it. You can either write it algebraically, or you can write it in interval notation. But if you put it in interval notation, you have to make sure you go from negative infinity to 0, including the 0, and then starting at 4 and going to infinity when you talk about domain. Okay, and then real quick, we could probably do number 16. You just have to be able to multiply. That's what this means. You want to take the two functions and multiply. You know, you could have something where you're taking the two functions and subtracting. But if you're multiplying those, all you need to do is write that down. You want to take 0.25 x to the 1/3 times g of x, which is negative 4x to the 3/2. Okay? And so now you just have to multiply. You need to take negative 4, I'll do that on my calculator, negative 4 times 0.25. I get negative 1. Oops. And then you have to take x to the 1/3 times x to the 3/2. And again, use your calculator for that. Add those. Remember, when we're multiplying like bases, we add the exponents. So I just need to take 1 divided by 3 plus 3 divided by 2. I want to know what I get when I add those. That's an ugly decimal, so I hit the math button. I convert it to a fraction. I get 11/6. So it's x to the 11/6 power. Now, you have a negative coefficient, that's okay. You can't have a negative exponent. So you can leave it as negative or negative 1, x to the 11/6 power. But then it also says state the domain. So we just have to look at our x's, and I would probably look at the original problem here. You're going to take the cubed root of x, that's what x to the 1/3 means, and the cubed root of x, the domain is all reals. But with this one, because the base is 2, you're going to take the square root of x to the 3rd power. So when you're thinking about a square root, the domain of a square root is it's got to be greater than or equal to 0. You can't take the square root of a negative number. So because you're here taking the square root of x, you know your domain is x has to be greater than or equal to 0. Okay? I'll do the 17 and 18 on the next video.